configuring VXLAN overlay. Now, if you remember the topology that we have, in this topology, we can see there is a VPC. Server 1 is connecting to two leaves. LACP is running on server, and now there are two connections from the server, and these two switches forms the VPC domain. So this we need to configure. Secondly, we are talking about overlay, which means we also need to configure VLAN to VNI mapping. In that we saw, and also you see here, there is a router. So we are going to have layer 3 out as well as layer 2. Layer 2. So when you do VLAN to VNI mapping, you will be mapping the VLAN number like 100, 101 to VNI number. Plus, you will also have a VNI for L3. For the L3 traffic to use the tunnel, there is a need for tunnel ID. That is what you will see here in this tabular column. In this table down here, you can see L3 VNI. This you will configure only on that leaf 4. And these are L2 VNI. In L1, in leaf 1, leaf 2, leaf 3, you will configure all of it. But on leaf 4, leaf 1, leaf 2, leaf 3, you will configure this VLAN to this VNI mapping, this VLAN to this VNI mapping, this VLAN to this. We will do all of it. But on leaf 4, it is not needed. The reason is leaf 4 don't have any layer 2. It's a WAN leaf. It's the edge. It's the edge of the VXLAN fabric. It connects to the WAN. It's the edge. So this one and this one, we configure, only these two we configure on leaf 4. Not all of them. Only this mapping and this mapping we configure on leaf 4. On the other 3 leaf, we configure all of this. Fine. After this, what? After this, we need to create NVI, Network Virtualization Edge Interface. And for the NVI, we need to allocate multicast address. It is not mentioned. You can give any multicast address. For each VNI, we will provide a multicast address. What else? Okay, tenant. I can see there are 2 tenants. Using VRF, we create 2 tenants. Tenant helps to isolate one tenant. Sorry, VRF helps to isolate one tenant traffic from another. And what else we see? Okay, here is the multicast address. I thought they didn't give multicast address. Here is the multicast address. For this VNI, this is the multicast address. Where do we configure these things? We configure these things under network virtualization interface. This is the tunnel interface for VXLAN, NVI1. Under this, we do for this VNI, this is the multi. Okay, they also have given SVI. This is the floating gateway address. For VLAN 101 member, this is the floating gateway address. So this address will be available in all three leaves. All three leaves, first three leaves. This is not needed on layer 3 SVI because IP redirect will happen on layer 3 routers. Layer 3 routers will direct the packet. It will just see the destination address, it will route the packet. You don't need an IP address. But on the switches, when you create a layer 3 interface, there is need for an IP address. Only then the encapsulation, decapsulation all will happen. So they have given almost all the informations here. But for configuring VPC, we need a keep alive link IP address. Do we have it? It's not here. When you create VPC, you will be having a layer 3 link to send the keep alives. That information is not there. We will find it there in the present in the lab guide. So whatever I have said is what you're going to see now. The sequence in which we do may vary from my style to this. Let's see what sequence this guide goes. This router will already have an IP address. And this has got that floating IP address of same subnet. So when they send the traffic, they send it to this address. So why there is need for another IP address? For example, if you have a floating gateway address 192.168.0.1 as a floating gateway address for VLAN 100, for that same VLAN, I think you use 101 and 102. For 101 VLAN, here router on a stick interface will have 0.2. 192.160. So the packet, when it is sent with this destination address. It learns the MAC address of this particular interface and delivers the packet here. So there is no need for an IP address on layer 3 SVI. Leaf 4 is not a gateway. Who is the gateway? For WAN. For WAN, this is the gateway. And for this PC, who is the gateway? These leaves. This is layer 2, this is layer 2. So they only need IP address. Here you don't connect any servers directly because this is border connecting to the WAN. Only when servers are connected, you will need a layer 2 SVI, then you need an IP address there. Now, this is the one which I was talking to you. Very clearly here it is mentioned. Leaf 4 is called as a border leaf. It is not connected to the end host. Therefore, layer 2 VLAN VNI is not necessary. I want to add one more thing here. Layer 2 VLAN VNI is not necessary. Not only that, you also no need IP address on layer 3 SVI because it's layer 3 SVI. Just for forwarding the packet. It will do the IP redirect. IP forward. So therefore, layer 2 VLAN and VLAN usage. Now, in this scenario, the goal is to build VLAN to VNI reference to match the table. Now, I showed you the table. In reality, it is only one additional command that most people are not familiar with. The only additional command is to associate the VLAN, VNI to VLAN. This is the command, VN segment. All right, so let us go and see that. So on all these three leaves, after enabling this feature VN segment VLAN based, you create each VLAN in all these three leaves, optionally give name, and you give the segment ID, very important, according to what is given in the table. You do that, do that, do that. Now, there is also one VLAN given for layer 3. For that also you do. Here you do. Next, you save it. But on the leaf 4, you don't need all this, you need only this two. Because in leaf 4, you are not going to receive any packet with VLAN 101. Correct now? In leaf 4, do you have any end device? No. There is no server connected directly to the, because it's a border leaf. So there is no need for that VLAN 101, these stuff are not necessary there. It needs only the routing stuff. Packets are coming to leaf. Packets are coming to the leaf gateway if it needs to go to WAN. So now, once it comes to gateway, it needs to take a tunnel that takes here. What is the tunnel ID? This is the one. 10,101 and 10,102. So using that specific tunnel, it will come here. And this will do IP forward, IP redirect. So there is a special tunnel needed for layer 3 and special tunnel needed for layer 2. We already have layer 2 tunnels configuration in the three. Oh no. In those three switches there. These are all for layer 2 tunnel identification. VXLAN tunnel IDs. But for layer 3, we have this. So it will put in this one so that leaf 4 can receive it. So leaf 4 also should have same VNI, only then it can receive. Whatever those leaves send, it will receive and do IP redirect towards the edge route. Is that clear? Okay, now going to the tunnel configuration. This is where we need to assign multicasting. Okay, before that, here what we do is they're talking about tenants. Okay, first let's create tenant, then we'll go to tunnel configuration. So VRFs are used to separate different tenants. In our lab, we have two tenants. This is how we configure VRF context tenant. Route distinguisher auto. This is the layer 3 VNI because VRF is what? Layer 3 control plane. Routing table. VNI. This is to include the VXLAN tunnel ID. See, tunnel is what? Tunnel is an interface, right? When you do MPLS, you create VRF, and then what you do? You go under the interface and say, this interface belongs to that VRF, correct? That membership only we are doing here. Here we don't have physical interface. This is overlay. So we are giving tunnel ID, tunnel interface ID. So this is how it works. All right. Okay. That I think here they have nicely written here. They do not need to have proper VNI configuration about to match the additional router let's go to customer. This is for EVPN. Okay, fine. This is normal VRF then only. We know this story. And this one, what I said is what the story. They're saying additionally you need to add this. Usually, how you do VRF, you configure. Additionally, you add this router. That is what they're saying. According to me, this is an unwanted sentence. Not necessary. So, is this part clear for you? So, where do you configure this? This you configure on all leaf because all leaves need to have layer 3. Leaf 1 to leaf 4, leaf 2 to leaf 4, leaf 3 to leaf 4. Will there be a layer 3 tunnel between leaf 2 to leaf 1? No. That's not WAN out. Okay, here comes the VXLAN tunnel. This is where the tunnel interface is created. Only on leaf 1 and leaf 2 and leaf 3, we create the NVE with all this. Whereas on leaf 4, we will have only this. So first, let us see for the first 3 leaf. Interface NVE1, you are sourcing from Lubax. That is good because you will have redundant path in the fabric. And also we say refer the BGP table for the remote tunnel endpoint. So we are going to use EVPN, right? So EVPN is the one which is going to act as a control plane. BGP table is that control plane. So we are saying we are not going to statically form tunnel. We say host visibility protocol BGP. We are not saying increase duplication, or we are not configuring anything static. Increase duplication is multicasting. Okay. Now this is for VLAN 101. We have this VNI. For all the traffic coming from VLAN 101, this is the multicast address using which the tunnel will be established. For 102 VLAN, this is the VNI. This is the multicast. Blah 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 blah. You know all these things. So how many tunnels? 4 tunnels. This is layer 2 tunnels. And this is for layer 3. And this layer 3, you remember we already associated with VRF. We are calling, VRF, blah, 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 associate VRF. So whatever the VRF in which we have mentioned this, that is the interface that will be mapped to this, meaning you are mapping the layer 3 tunnel, VXLAN tunnel into this. Correct. VRF is for saying these interface belong to one customer, one control plane. You may have many interface. See here, all these are tunnel interfaces. All these are tunnel interfaces. This is one tunnel, this is another tunnel, this is another tunnel, this is another tunnel. This is also a tunnel for one customer. This is a layer 3 tunnel, layer 3 for layer 3 purpose. This is also another tunnel for another customer for layer 3. We need to say all these tunnel will be using this NVE1. You need to understand this very well. Do you know GRE? Do you know GRE? Okay, good. Do you know DMVPN? Okay. Now let us take DMVPN. Where do you configure the DM, NHRP, all the stuff? Under the interface tunnel, correct? Because you use the command interface tunnel, is the tunnel ready? Now, listen. Tunnel gets ready only when the communication happens from one spoke to another. So tunnel interface is just an interface which will be used to create a virtual connection later. Tunnel interface is for negotiation. So what I'm saying is, this is what tunnel interface. Why you are talking another tunnel or not? 2, 3, 4, 5, 6 tunnels. I have only one tunnel interface, which is called NVU. Don't say that. This is the syntax called interface NVE, which will negotiate tunnel as the traffic enters. And for VLAN 100 member, there will be one VXLAN tunnel. For VLAN 102, another VXLAN tunnel. How do I know? Because I have different multicast address. Okay, let's move on. Here comes leaf 4. As I told in leaf 4, you need only these configuration. No need of multicast address because you are purely layer 3 BGP. Why you need multicast address? No need, isn't it? Yeah. So the tunnel interface configuration is over. Now EVPN. Okay, before that you verify. You see the tunnels are up. How many tunnels? 1, 2, 3, 4. Totally 6 tunnels, I think. Yeah, this is layer 3. See? Layer 3. Up. Now, EVPN, in the global mode, you say EVPN, and for this VNI, route distinguisher auto. For this VNI, route distinguisher auto. For this route distinguisher auto. Route target, both auto. We need to say. Okay, this is repeated twice. This is repeated twice. This, I don't know why they did. Now, so for all this, they say route distinguisher auto, route target, both auto. This is under EVPN. Now, you need to understand this very clearly. Before you did under VRF, that is layer 3. This is layer 2. This is layer 2. Under VRF, you said earlier, route distinguisher, route target, both auto, EVPN, blah blah. You say that is layer 3 under the address family unit. This is EVPN. EVPN is a layer 2 concept. Okay, so we clearly say it's layer 2, blah blah, and then finish. Is there any problem up to here? Any question up to here? Which 12? This is not 12, L2. Layer 2. Now, next is BGP. BGP, configuring BGP for tenant routing. Okay, tenant routing, fine. Enter the following command to add layer 3 routing capability across the fabric, adding the VRF information to BGP. Put all the data into BGP L2 EVPN table. Utilize the route map. Okay. Utilize the route map. Utilizing a route map will bring all SPI interface subnets into BGP process as well. This is what I was telling you. You need to have a dedicated IP address for each subnet to be used as a gateway that need to be advertised by BGP. That we need to do. Let's see how they do. Here, Correct. Whatever, to VRF or to outside also, you need a gateway. And that gateway need to be known to BGP. The gateway need to be known to BGP. So let's see. On all four leaves, we create this route map and we are tagging 1, 2, 3, 4, 5. Why? Maybe we will know later why we are tagging. So here we are just giving one ID to match all the permitted traffic. 1, 2, 3, 4, 5. So it is like whatever BGP is learning from the leaf, the connected device information, when it learns from the leaf, we give this tag. Why? You will know only later. I will also know. Okay, rest all we deny. Now we go to router BGP. We are going to VRF net. We say redistribute direct using the route map. Direct. For all the directly connected interface, what this will do is it will provide ID 1, 2, 3, 4, 5. That's all it is done so far. So now let us go to creating SVI so that we will come back again to understand that tag 1, 2, 3, 4, 5. Here SVI utilizes any case gateway, which is nothing but floating gateway. This feature puts same IP address for each network. You need to have same IP address. Not only that, you need same MAC address. You should have all the three leaves with the same MAC address. IP address they have given in the table column. The gateway IP address, the floating IP, here it is. For all two tenants and for both VLAN 101 and 102 and 201 and 202, they've given SVIs. But what is not given here is the MAC address. You can write any 48-bit value, no problem. Don't copy from your laptop and put one MAC address that will conflict your laptop later. Just put randomly some number. If they give you, use it. Here they have not given. Address on each of the leaf switch for the host. Okay. It specifies the universal MAC. It specifies the universally means universally. Don't think that world level universe. It's for this VXLAN fabric. It is universal, meaning same MAC address for all the switches to use, so that if the host migrates between the switch, the gateway MAC address does not change. Our problem will not come. See, why do we have floating MAC address for VRRP, HSRP, GLBP? Same reason here. There you have a dedicated MAC address for HSRP, dedicated MAC address for VRRP, but here they have not given, so we can give any. Fine. This is the command. Yeah, correct. Yeah, not only two VRA, you can have any number of VRA. You have one common gateway, that's all. You see, we need to create the SVI. So this is the command to enable the feature SVI, interface feature, interface VLAN. Interface VLAN is what we call it as what? SVI, right? So enable this feature on all four leaves. And create layer 2 SVI only on this three leaf. Only on that three leaf, you need this floating MAC address. Makes sense, right? This three leaf only is going to do routing. This three only needs to have floating IP address and floating MAC address. Pervasive gateway. You got it? So you say fabric forwarding, any case gateway MAC address, some number 1, 2, 3, 4, 1, 2, 3, 4. And then go under interface VLAN 1. You say this interface is a member of tenant 1. This is according to this table. Tenant 1. and this should be the IP. You see? Now you call the tag directly connected, all directly connected members. Some member will be member of VLAN 101. They can use it as a gateway. Some will be the member of 102. They can use this as a gateway. You see why we used to tag earlier? Now this is also given to BGP so that BGP will also know the location of these networks uh, to advertise the info between the leaves, leaf 1, leaf 2, leaf 3, and leaf 4. So we have, listen, listen, listen. Tag is to match directly connected. Yes or no? That is what we saw in the route map earlier. You saw that, right? Route map was named as direct, but when you say redistribute in BGP, what did you say? Redistribute direct, use route map direct, correct? What is connected directly? Here 101 is connected. Here 102 is connected. For tenant 2, 201 is connected here. 202 is connected here. That is what connected, right? For both these three leaves are gateway, right? Then why you need different tag? VRF is going to separate them. You don't need to do any separation in tags. VRF will take care of it. You can have same tag, no problem. Because these interfaces, the tenant interfaces, are in different VRF. Tenant 1 is in one VRF, tenant 2 is in another VRF. This tag won't conflict. See, in MPLS, if we can have same subnet in different VRF, tag also can be the same. In MPLS, when you have same subnet in two different VRF, tag value also can be same. Tag is also matching what? One IP address only. Same logic. Okay. Now this you put in all the switch, and then in all the switches, this means layer 2 switches, layer 2 leaves, you map the SVI IP address and to which VRF they belong to, membership, VRF membership. Is there any question in this? No. Now, okay, this is also same thing. Now, this is only on, sorry, this is only for layer 3 SPI. Layer 3 SPI, no need an IP address. So you say interface VLAN 1001 is not 101. 1000 is a dedicated VLAN. And this need to simply carry the traffic from leaf to the fourth leaf, from any leaf to fourth leaf, depending on the routing destination IP. If it is coming from tenant 1, this tunnel 1001. If it is coming from tenant 2, this tunnel. So for routing purpose, you need one wire from for tenant 1, another wire for tenant 2. So we create that wire here. It is just a tunnel. Anything put in the tunnel, it will go directly via leaf 4 to the router out. WAN router. So there is no need for any layer 3 in the middle. Next. This is normal. Now, VRF to VRF only one VRF. No. VRF to VRF illa. If you want to do VRF to VRF, see, someone from VLAN 101 wants to go to internet, yahoo.com. This subnet needs a gateway, so there is a gateway here, here, here. And for this, the next stop is this. So when he tries to go Yahoo, traffic comes here and gets the MAC address of this and delivered here, and rest of the thing this will take care. This is L3 out. Now, if someone from 101 wants to talk to 102, which is of same VRF, that is possible. But 201, which is of VR tenant 2, so these two are tenant 1. This is possible. This layer 3 is possible. But this is different VRF. Sorry, correct. Different VRF. You cannot ping from here to here. If you want to ping, the packet should go out, and if this guy allows you to come back, then you can come back. Otherwise, it is not allowed inside. They are not teaching that route leaking and all. You can do route leaking and do that, but here that is not taught here. Route leaking, if you do what you ask, is possible between two VRF. But here, the reason why you have two VRF, in order to separate only, then why you talk about merging. If you want to ping, then you will not first of all put them in different tenant, different VRF. Now, this is normal layer 2 configuration. This is connected to the server. Server 2, server 3, you configure. Leaf 3 and these two interface. You configure and try pinging, it is pinging. But for server 1, server 2 to server 3. This to this. These two are in same switch, but different interface. That is why you saw here Ethernet 1/3 in leaf 3 is 101, which is of tenant 1, and 101/4, not this one. Okay, here. No, you didn't see properly. Actually, my keyboard jumped to a different page. You see, this is page number 23. Leaf 3, Ethernet 1/3. All right, leaf 3, Ethernet 1/3. Same leaf 3, Ethernet 1/4, and the VLAN is 101. See, 102. Same tenant. Don't get confused. இவ்வளவு நேரம் பேசின பின்னாடி நீங்க அதே கன்ஃபியூஷன் இருக்கீங்க எனக்கு ரொம்ப ஆச்சரியமா இருந்துச்சு I can't ping if it is different tenant. Here I am seeing pinging, which means it's just the same tenant. Okay. உங்களுக்கு உங்க டவுட்டுக்கு ஏற்ற மாதிரி பேஜ் இங்கே ஜம்ப் ஆகி போயிடுச்சு உங்களுக்கு இன்னும் கொஞ்சம் குழப்பத்தில் தள்ளிடுச்சு Now, for server 1, it's not normal because server 1 has got two connections to two different leaf, and these two different leaf need to be combined as one single virtual switch. For that, you should know VPC. VPC is the LACP between, in this example, between the server and this virtual switch. This is like the switch, server, two connections. But this is not really one, this is two. For that, what is needed? These two should have a keep alive interface. Keep alive interface is a layer 3 interface which needs an IP address here and IP address here to ping. What IP address they use? You can give any IP address. Here they have not given. They have not given. Maybe in the document they will give. Okay, so enable VPC, enable LACP, create a context, means VRF, go to the address family and say this interface is a member of this VRF. This is the interface that connects to the uh, server down. And that interface is a member of this context. This context is going to be VPC now. Now you see, if you go down, they are giving an IP address. This IP address is not mentioned in the table, but here they are using. This is a layer 3 interface just for keep alive. So I need to change my word. தப்பா சொல்லிட்டேன். அடுத்து என்ன வருதுன்னு பார்க்காம சொல்லிட்டேன். This interface is not the interface connecting down to the server. Not. Then what is this interface? This interface is the interface which I have drawn here. This one. Okay, that's the layer 3 interface for keep alive. உள்ளேனையான்னு ரெண்டும் கத்திக்கிட்டே கிடக்கும். So now, what is the address we have given here? கஞ்ச பசங்க ஐபி அட்ரஸ் வந்து இப்படி யூஸ் பண்றாங்க பாருங்க /30. So 0/31 if you put 0 is also included as an address. Host only address. So what you do, you create VPC domain 10. You should use the same number on the other leaf 2 also. And you say from this source means what? From your 1/5 interface to this address. This is whose address? Leaf 2's address. If you go down, you can see that here. From leaf 1 to leaf 2, using the context, using the VRF, you are sending ping messages. All right. These commands are necessary. Next, this is the interface that will be used as a keep alive, peer link. You see, you go to this two interface and say this belong to port channel 100. What is port channel 100? It's a VPC peer link. So if you know VPC, you will know what I am showing you. Same thing you repeat on switch 2. The VPC will also come up. Show VPC is the command. It shows that the adjacency is okay, peer link is alive, everything is looking good. All these VLANs are allowed in. That's all. Now you should ping from anywhere to anywhere. Okay, this is down facing. This is the interface to which the server is connected. That belong to 101 mode active. Right? That is all. That's all actually. Wait. This is on leaf 4. We have a sub interface, and this is the IP address for VLAN 10 and VLAN 20. What is this? What VLAN 10 and VLAN 20? Have we ever used this address 172? Nowhere in this table. 172.16.3. Okay. This is only between these two. Yeah. This is in one network. So you create a layer 3 interface for this to ping so that people can ping from here and here. That's only for server 3. Sorry. So, all right. So you are pinging from 172.16. That's a part of outside WAN, 172.16 network. You are able to ping from leaf to outside server. This is for BGP. Normal BGP with the remote router, WAN router. All right. So the other things, you check, it will be a known story only. This is normal BGP. Okay. I think they are filtering here. Oh, yeah. See, you do not want to advertise your local networks. Which networks? 192 networks outside. So you block everything less than or equal to 30. All you block. Here, if you permit, nothing. Permit what? Nothing. Permit nothing, which means outside to EBGP neighbor, it is not going to advertise any routes. That is what you are doing at last. You see, usually we will have, that is what we do. Usually we don't allow our private network to go to WAN, right? Yeah. So we need to filter that because we need it inside. We want BGP to advertise inside. We don't want it to advertise outside. So we put a filter here for these subnets, all subnets. So nothing goes from inside to outside as an advertisement, but from outside it will come.